Learning Target 2 says I can use the factor and remainder theorems. So in this little box I've put some reminders about what the factor and remainder theorems say. So the first thing we need to remember is when we divide a polynomial, f of x, by something of the form x minus a, the remainder of that division is just f of a. Something that follows from that is, suppose that we want to figure out if something of the form x minus a is a factor of the polynomial. The remainder from the division, f of x divided by x minus a, that remainder has to be 0. But using the first bullet point, if we know the remainder is just f of a, that would just mean that f of a needs to be 0. So we're going to do a couple of different problems. One where we're trying to just find the remainder, one where we're trying to decide whether something's a factor of another polynomial, and one where we try to find a constant that makes something a factor of the polynomial. So let's get started with this first problem. So this problem asks us to find the remainder when you divide this polynomial here by x minus 1. So when I say find the remainder, that just means I want you to figure out what the remainder is of this division problem. You don't need to say anything about whether this x minus 1 is a factor or not. So make sure you read the directions carefully. So to find our remainder, we're going to use the remainder theorem. We know that the remainder of this division is just going to be f of a, or this polynomial evaluated at our a value, which in this case is 1. So to find the remainder, our remainder will just be equal to the polynomial evaluated at 1. So I'm just going to put 1 into my polynomial. And then I'm going to simplify. So using order of operations, we're going to do all of our exponents first. So 1 cubed is 1. 1 squared is also 1. Next in our order of operations, we're going to do all of our multiplication. So I see I have multiplication here and here. So 2 times 1 will be 2, and 3 times 1 will just be 3. And now I can just add up all these numbers. So 1 plus 2 will be 3, minus 3 is 0, plus 4 is 4. So our remainder here will be equal to 4. So once again, all we did here was we used the remainder theorem, which said that the remainder of the division, when we take a polynomial f of x and divide it by x minus a, the remainder will just be f of a. So in this case, our a value was 1. So we just took 1 and plugged it into our polynomial and simplified down, and we got a remainder of 4. So moving on to the second problem, and this problem is asking you to determine whether this is a factor of 3x squared plus 5x minus 2. So be careful. The directions here are asking you to determine whether something is a factor. So we not only need to find the remainder, but once we find the remainder, we have to decide whether x plus 2 is a factor or not, based on whether the remainder is 0. But let's just start by finding our remainder. So the remainder theorem says that if we divide a polynomial by something of the form x minus a, the remainder is f of a. Now there's something a little bit different in this problem. The thing that we're dividing by, x plus 2, that is not quite of the form x minus a. See how it's x plus a number rather than x minus a number? So the first thing we're going to do is we're going to rewrite that x plus 2 as being x minus a negative 2. So these two things are equivalent. So remember that subtracting a negative number is the same thing as adding a positive number. So if we have x plus 2, it's okay to rewrite that as x minus a negative 2. And then the thing that we're dividing by actually is in this format that we want of x minus a. And we just see our a value is this negative 2. So to find our remainder, we're just going to take that a value, which we now see as negative 2, and we're going to plug that into our polynomial. Now, if you notice, each of the places where I put a -2, I put it in parentheses. So it's a really common mistake to write something like this as, for example, I'm just going to put it up to the top. When people write it like this without the parentheses around the -2, it's really easy to forget that you're squaring the whole -2 and not just the 2 part. So I'd really encourage you to make sure that you put your negatives inside parentheses like this. That's super important on your calculator, because if you mean to plug something like this into your calculator but you type it like this, your calculator is going to misunderstand and it will only square the +2, not the negative. So that's really important to be careful about on your calculator. Okay, so now that we have this written out, let's just use order of operations to simplify. So the first thing that we have is we have exponents. We have -2 raised to the second power. And -2 squared is just going to be 4, so we can rewrite that as a 4. Now we can go through and do all of our multiplication. So notice we have multiplication here and here. 3 times 4 will be 12. 5 times -2 will be a -10. And then we just have our -2 at the end. So next we can just add up all these numbers. 12 plus a -10 will make a +2. And then when we subtract off 2, we will get a remainder of 0. Now, we're not quite done yet, because the directions said to determine whether x plus 2 is a factor of this polynomial. So it didn't just say to find the remainder, it said to determine whether x plus 2 is a factor or not. So now we need to make a conclusion based on what the remainder is this a factor or not? Now, something's only going to be a factor if the remainder of that division is equal to 0, right? Because that's sort of the whole idea behind a factor, is that it would divide evenly into your polynomial. And it only divides evenly into your polynomial if you get out a remainder of 0. So to determine whether x plus 2 is a factor, we have to look at our remainder, and based on the remainder, decide whether that factor would divide evenly into our polynomial. So in this case, we got a remainder of 0. If we get a remainder of 0, that means that the x plus 2 would divide evenly into our polynomial, so therefore it is a factor. So since the remainder of our polynomial divided by x plus 2 is 0, we know x plus 2 is a factor. So remember to just read your directions carefully and make sure that you're asking the question that's asked. This one asked us whether x plus 2 is a factor, so we need to actually answer the question after we find the remainder, whether or not x plus 2 actually is a factor. If we had gotten any remainder other than 0, x plus 2 would not have been a factor. So our last problem is a little bit trickier. So this problem is asking us to find a value of this constant k, such that x minus 2 is a factor of this polynomial here. So remember, in order for x minus 2 to be a factor, the remainder that we would get from the division of this polynomial divided by x minus 2 would have to be 0. So the first thing we're going to do is we're going to find the remainder of that division, and we're going to set the remainder equal to 0, because the remainder needs to be equal to 0 for x minus 2 to be a factor. So let's go through that and sort of see what happens. So let's first calculate our remainder using the remainder theorem. We know that the remainder will just be equal to this polynomial evaluated at 2. So let's find this polynomial evaluated at 2. We would get 2 cubed minus 3 times 2 squared plus k times 2 minus 8. So all I did was I took my polynomial and I plugged in x equals 2. So I can simplify this as much as I can. Using order of operations, I'll first take care of my exponents. 2 cubed is 8. 2 squared is 2. And then everything else I'll leave alone. Notice I rewrote k times 2 as 2k just because we usually put the 2 in front of the constant. So now let's simplify a little bit more. We can simplify this minus 3 times 4. That becomes a minus 12. Now notice that we have a bunch of numbers here. We can add those up. 8 minus 12 would be negative 4. Minus an 8 would be negative 12. So we get negative 12, and then we still have plus 2k. So the remainder of this division, if we took this polynomial and divided it by x minus 2, the remainder of that division is negative 12 plus 2k. The whole idea is that we want to make x minus 2 be a factor of this polynomial, so we want to make the remainder be equal to 0. And we want to find the value of k that would make that happen. So I'm just going to make my remainder be 0 and solve for k. So now this is just a simple equation that we know how to solve. We're trying to get k by itself. So the first thing I'll do is I'll add 12 to both sides to get rid of this little minus 12 over here. If I add 12 to both sides, I get 12 equals 2k. And then I'm going to divide both sides by 2, and that gives me that 6 is equal to k. So my final answer is that k is equal to 6. So this was a bunch of different steps, so let's just review the steps that we did. We wanted to find the value of k that made x minus 2 a factor of this polynomial. So the first thing we did was we figured out what the remainder of that division would be. Now since k was inside the polynomial, our remainder was in terms of k. Now we wanted to make x minus 2 be a factor of the polynomial, so we knew that our remainder would need to be equal to 0. So the next thing we did was we just set the remainder equal to 0, and we solved for the value of k that would make that happen. And we just did some algebra, got down to the fact that k is equal to 6. So the idea here is that if we took this polynomial and we plugged in k equals 6, the polynomial that we would get would actually have x minus 2 as a factor.